So the unit on polynomials, we're going to begin by looking at how to use our calculator. I have here these are basic instructions for using the calculator, but let me just show you where some of these buttons are. So if you want to graph an equation, you're going to press y equals. That's way up on the top left here. What that allows you to do is graph multiple equations. You see there's y1 all the way down to y7. You can do all of those equations at one time. Usually we're just going to do one at a time. Okay, if you notice right on the top of the screen it says plot 1, plot 2, plot 3. Those have to be like this. If they are, if there's a solid black square around them, that means that plot is on. You don't want the plot on if you're graphing a line here. Okay, so that's what it means by turning the plot off. To do that, you could just go there. If you press enter, you can see now it's solid black. There's a black square, but we don't want that, so we're going to press enter again to turn it off. Okay, you can type in the equation. We'll do many of those, so you'll see how that looks. And then you're going to graph it. If you just press graph, it'll graph. It might show up or might not. You have a few options here with zoom. Okay, usually zoom 6, which is the standard window, is a good one. Okay, sometimes that doesn't work and it's not going to show out. You might want to zoom out or zoom in to get closer or further out. And sometimes we can adjust the window manually. So here's the window. This is a standard window. If you go zoom standard, this is kind of what you get. Sometimes we want to look at a bigger screen, and we'll do examples of that. Okay, so let's go back here and let's just put an equation, and I'm just going to go 2x minus 6, and then I'll graph. So I get a graph like this. Okay, so let's go to the second thing, to find an x-intercept. The x-intercept is where it crosses the y-axis. Okay, to figure that out, we're going to press second trace, so not trace, but second trace, and then it gives us some options here. Number 1, value, you're going to use that if you want the y-intercept. Number 2, 0, you're going to use that if you want the x-intercept. And then 3 or 4 will allow us to find the maximum or the minimum. Okay, so I'm just going to leave it there, and then we'll do this with some of the questions coming up. Okay, so let's move ahead here. Exploring the graphs of polynomial functions. What is a polynomial function? Well, a polynomial function might look like this. So let's write 3x squared plus 2x minus 6. Let's say that. Okay, it contains only the operations of multiplication, addition, subtraction with real number coefficients, so there's no square roots or cube roots or something like that. Okay, and then there's some variables. Alright, here's the multiplication in this. It's 3 times x squared, and then here's an addition, here's another multiplication, and here's subtraction. Okay, so that's a polynomial function, and there's many more. And you'll see what some of those look like as we go through this unit. Each part of the function is called a term. So if you look at that previous question, a term, this is one term, this is one term, this is one term. Okay, each term has a coefficient. All right, if I look at that example right here, my coefficients would be 3, 2, because those are both numbers that are in front of variables. Those are coefficients. Okay, there is also what we call a constant. A constant is not attached to a variable. In this case, it's minus 6. Okay, the term containing the highest power of x is called the leading term. So which term had the highest power of x there? That would be 3x squared. Okay, that's the lead term because it has the highest power. And we refer to the leading coefficient, in this case, is 3. Okay, the power of x containing the lead term is called the degree. So the highest power, we refer to the degree. In the first one, there is no power of x, so the degree is 0. In the second one, the degree is 1 because the power of x is 1. Highest power of x in the next one is 2. And then 3, and so on. And we can have higher powers as well. For example, power of 4 would be a quartic, power of 5 would be a quintic, power of 8 would be 8th degree, Okay, not really worried about those ones higher than cubic. Most of the questions we're going to get will be cubic or less. Okay, and most of these graphs we're going to have to answer some of the questions relating to their characteristics. Okay, we've got the domain and range. If you remember, domain is the set of x values. Typically in a polynomial, this will be negative infinity to infinity. The only time it's not going to be negative infinity to infinity is if we have restrictions based on a scenario. So let's say, if you throw a ball into the air, then you're going to have some restrictions on the time because the ball doesn't stay in the air forever. Okay, but if you're just getting a graph, you're going to have the domain be from negative infinity to infinity. The range will be dependent on what kind of graph you have, and we'll get into things like that, but the range is the y values. The x-intercepts, that's where the graph intersects the x-axis, and it's always where y equals 0. The y-intercept is where x equals 0, and it's where it crosses the y-axis. End behavior, this is the description of the shape of the graph from left to right. So as we read from left to right, what's happening to the graph? Really, what we're wondering about is what's going on sort of when the x value gets towards infinity. Like we're saying, is it going this way or is it going this way? Okay, we'll talk about those with examples. The turning point is if the graph changes direction. Okay, so let's try some examples here. So we'll start with the basic one, the degree 0. This is called a constant function. Okay, so let's get out our calculator and we're going to graph this. So we'll go to, I want to go to y equals, and I'm going to clear this. And I want to graph. And notice it says f of x equals 4. That's the same as y equals 4. Okay, so I'm just going to put a 4 in there, and then we're going to graph. And so the graph looks like that. Okay, so what's the domain? Well, you can see that line. That line here at 4 goes on forever in both directions. So the domain will be negative infinity to infinity. The range, well, the range in this case is just y equals 4. It's the only thing it can be. The y-intercept crosses the x-axis at 4. There are no x-intercepts. Slope. Well, you have to go back to grade 10. And if you remember y equals mx plus b, the slope was always the number in front of the x with a line. Well, this graph doesn't have a term from x. Really, it's y equals 0x plus 4. This has a slope of 0. And that should make sense. We have a line that is going straight across. It's not getting any higher or lower. It's not rising or falling. And the end behavior. So there's a couple of ways you can answer this. We can say it's moving from quadrant 2 to quadrant 1. So if you remember the quadrants, this is quadrant 1, this is 2, this is 3, this is 4. Okay, but I would like to say, as x approaches infinity, okay, so I'm going to just go a little bit different here. As x, and we use this arrow, as x approaches infinity, y, or we'll say the graph moves to quadrant 1. Now this is a bit of a weird one because it's not rising or falling, but usually we can say as x moves to infinity, the graph is rising or falling. But for this one, we'll just leave it at that. There are no turning points. Okay, so that's our first try. Let's look at another one. So this one, hopefully this will remind you of y equals mx plus b. We spent lots of time in grade 10 on that. So let's go here to y equals. We're going to clear it, and this time we're going to go 3x plus 1. All right, and graph it. Okay, so there is our graph. Let's write what we can see. The domain is negative infinity to infinity. The range is negative infinity to infinity. I'm not going to draw this yet, but you could see that this is going forever in both directions. Okay? The reason I'm not drawing it yet is I want to know what the y-intercept and what the x-intercept is. So let's go and find those. So let's do the y-intercept first. To do the y-intercept, we're going to go second, trace, and remember the y-intercept was done using value, so I'm going to press 1. And it says x equals what? We're supposed to put something in there. Well, for the y-intercept, we're always going to put x is 0. And when x is 0, it's going to tell us what y is. So I'll press enter. So it says the y-intercept is 1. Okay, so let's write y equals 1. Okay, in fact, since we're asking for the y-intercept, you don't have to say y equals 1. We can just say 1. Okay, and then I'm going to show you my least favorite thing to do with this calculator. It's not very sort of user-friendly. Okay, and that's to find the x-intercept, which they call the 0. So we're going to press 2. And now you have something weird. It's called the left bound and the right bound, what we have to find. Here's what this means. Okay, so let's put the y-intercept already, and then let's just sketch this graph for a second. To find this point, this x-intercept, we're supposed to say, give it a left boundary, give it a right boundary, because the calculator is going to look in between our boundaries. Okay? In this case, the left boundary will be below the x-axis, and the right boundary will be above. So we have to tell the calculator where to look. Okay, so if you look right here, you see where the cursor is flashing? That's above the 0. So what I want to do is I'm going to use my arrows to go down here. Now I'm below the x-axis, so I'm going to press enter. So you can see this little arrow on the top here. That tells me that that's my left bound. Now I'm going to move my arrow to the other side of the x-axis. And you don't have to be too accurate here. So now I can see for sure I'm past the x-intercept. Okay, and I press enter. And now you can see that the boundaries that I've created kind of frame where the x-intercept is. It's in between those two arrows. All right, and it says guess. Well, I'm not going to guess. I'm just going to press enter. And it's going to tell me that the x-intercept, the 0, is negative decimal 33333. Okay, and you know that's negative 1/3. If you don't, the decimal's fine. Okay, and so we'll put it somewhere around here. And now you can make this sketch. Okay, and what I would do is I would label that negative decimal 33. And we'll label the y-intercept 1. It's nice to show what they are. Okay, what's the slope? The slope is the number in front of the x, so that's 3. What's the end behavior? All right, what's happening as x approaches infinity? We can say the graph is rising to the right. We probably don't have to say to the right. We'll just say it's rising. So in other words, as we go this way on the graph, you can see that the graph is going up. Okay. Number of turning points. Again, this doesn't turn. It's a straight line. Okay. Why don't you pause the video and see if you can graph this next one. Okay, so here's the graph. Just a couple of quick comments. Make sure when you enter this that first negative is the correct button. It's not subtract, it's negative. It's the little negative with the brackets in. And you can see that on my key history here. Okay, make sure you enter that correctly. Okay, so there is our next graph. If you quickly want to look at the x-intercept again, that's probably the trickiest thing to do. So let's go to find the x-intercept. We'll go to 2. Okay, and so I want to frame where it crosses the x-axis, so I can see I need to move this cursor to the left of that point. Okay, press enter, and then I want to move the cursor to the right of the x-intercept. And now I can see that I framed where the x-intercept is. If I press enter, it gives me -2. All right. I'm going to stop the video there. So I'll continue this lesson on another video so the videos don't get so long. Okay.